Welcome back, everyone. We're diving into the world of Archimedes today.
Oh yeah, Archimedes, a total legend.
Seriously.
Yeah.
And we've got these excerpts from a Spanish biography about him to dig into.
From a Spanish biography. Cool. I'm always up for a fresh perspective.
Me too.
Yeah.
And it's fascinating, because we have so much of his scientific work still around.
Treatises and diagrams, even some of his letters.
I know, right? But his personal life.
The total mystery.
It's like we know the brilliant mind, but not the man behind it.
Definitely adds a layer of intrigue, doesn't it?
Totally. But this biography, it doesn't just stick to the hard facts.
Oh. What else is in there?
It mixes in these captivating anecdotes and stories.
Ah. So we've got some fact-checking to do them.
We do. We're going to separate the eureka moments from the, well, maybe not so eureka moments.
Sounds like a challenge. So where do we even start with a guy like Archimedes?
Well, before we get into the specifics, I think it's important to remember the historical context.
Good point. Can't just look at him in a vacuum.
Exactly. Archimedes lived during the Punic Wars. Rome versus Carthage, battling for control of the Mediterranean.
Oh, wow. So not exactly a peaceful time to be conducting research.
Not at all. Imagine massive empires clashing, and in the midst of all that, you've got Archimedes doing his thing.
Must have been some serious pressure.
You didn't think so? And on top of that, our biography mentions this close connection to the ruler of Syracuse, Hiram II.
Hiram II. Wasn't he a pretty powerful guy?
Oh yeah, major player. And they might even have been related, Archimedes and Hiram.
Interesting. Makes you wonder how that relationship shaped his work.
For sure. Like Hiram, as ruler, he could have totally supported Archimedes' research.
Given him resources, protection, maybe even inspiration.
Exactly. And in return, Archimedes' inventions could have been used to strengthen Syracuse.
Like a win-win situation. Patronage in action.
Right. So Archimedes, he's not just this isolated scholar.
He's actively involved in the power dynamics of his time.
Totally. His work had real-world consequences. It could determine the fate of a city.
Really adds another layer to his story. Okay, so we've got war, we've got power. What else?
Well, there's another fascinating figure who pops up in the biography,
Oh, who's that?
a guy named Eratosthenes,
Eratosthenes. Wasn't he that guy who measured the Earth?
the one and only. And he did it using just shadows and geometry.
Wait, seriously, just shadows? That's incredible.
I know, right? It's mind-blowing.
So how did he pull that off?
Well, he knew that on the summer solstice at noon in Syene, Egypt, the sun was directly overhead.
Okay, directly overhead, no shadows, got it.
But at the same time in Alexandria, a stick planted in the ground did cast a shadow.
Uh-huh. So there's a difference in the angle of the sun's rays.
Exactly. And by measuring that angle and knowing the distance between the two cities,
He could extrapolate? Clever?
super clever, he figured out the Earth's circumference.
It makes you realize how much these ancient thinkers could achieve with limited tools, but with a deep understanding of the world.
It's truly inspiring. And get this, Archimedes and Eratosthenes, they corresponded.
They wrote letters to each other.
Yep. We know from Archimedes' own letters they were part of this network of brilliant minds.
Sharing ideas, pushing the boundaries of knowledge. Amazing. Okay, so we've got war, powerful rulers, a guy who measured the Earth using shadows. What's next?
Okay, now for the story everyone knows about Archimedes, the Eureka moment.
Ah, yes. The bathtub, the crown, pure gold or not.
The whole shebang. But is there any truth to it?
Well, that's where this biography gets really interesting. It challenges that traditional narrative.
That does.
Yeah, it dives into the practical limitations of what Archimedes could have actually measured back then.
So you're saying the bathtub story might be a bit exaggerated.
Let's just say the author casts some serious doubt on it. The math just doesn't add up.
So if not the bathtub, then how did he solve this problem?
Well, remember, Archimedes was a master of levers and balances.
Ah, so maybe something a little more practical.
Exactly. The biography suggests he probably used a balance scale.
A balance scale.
Yeah.
How would that work for figuring out if a crown is pure gold?
You'd compare the weight of the crown to an equal mass of pure gold, both submerged in water.
Oh, so if the crown wasn't pure gold, it would displace more water.
Right, exactly. And appear lighter on the scale. Simple but effective.
A much more elegant and frankly more believable solution.
Right. And it fits perfectly with what we know about Archimedes. He wasn't just about sudden flashes of inspiration.
He was all about applying his deep understanding of science and engineering to solve problems.
Precisely. He was a true innovator, constantly seeking practical applications for his knowledge. But the thing is, buoyancy, that was just one piece of his incredible legacy.
So what else can you tell us about this legacy? What other groundbreaking discoveries did he make?
Well, his legacy, it's huge. This biography really emphasizes how Archimedes, he wasn't just observing stuff, you
Oh,
know?
you mean like just noticing things?
Yeah, he was rigorously proving his ideas, using math.
And we're talking centuries before the scientific method as we know it today.
Exactly. It's like he was laying the groundwork without even realizing it.
He was a true pioneer. And this source mentions all these different topics he tackled. Levers, spheres, cylinders, spirals.
Oh, yeah, and don't forget pi.
Pi, of course.
Mm.
You know, the ratio of a circle's circumference to its diameter.
Had to throw that in there for anyone who needs a reminder.
Always good to have a refresher. But seriously, this guy, he was constantly pushing the boundaries.
Absolutely. And it wasn't just what he discovered, but how he did it. He developed new math tools way ahead of their time, like the method of exhaustion.
Okay, method of exhaustion. The name doesn't exactly scream exciting.
I know, right? But trust me, it's more interesting than it sounds.
All right, I'm all ears. What's this method of exhaustion all about?
So imagine you're trying to find the area of a shape, but it's not a simple one like a square.
Okay, something more complex, like a circle.
Exactly. Archimedes, he'd break down that complex shape into simpler shapes that he could measure.
So like fitting puzzle pieces inside the circle.
Yes, and he'd keep using smaller and smaller shapes, getting closer and closer to the actual area.
Ah, I see. So instead of measuring the circle directly, he's filling it up with measurable pieces.
Precisely. It was tedious, for sure. But it let him achieve amazing accuracy.
So it was about finding the answer, but also about finding it with incredible precision.
Exactly. And believe it or not, this method, it's actually considered a precursor to calculus.
Calculus. Now there's a word that brings back some memories, mostly of confusion.
Uh-huh. But think about it. Archimedes' work helped lay the foundation for this fundamental area of math.
It's mind-blowing when you think about it that way.
It really is. But you know, his legacy isn't just about what he discovered. There's also a layer of mystery. Remember how some of his writings have been lost?
Oh yeah, you mentioned that earlier.
Yeah.
Besides that whole optics thing. Still bummed about that one.
Well, there's this whole other story that sounds like something out of a movie. It involves a medieval manuscript called the Palimpsest of Constantinople.
A palimpsest. Okay, gotta admit, I don't know what that is.
It's basically a recycled manuscript. Parchment was expensive, so they'd often scrape off old text and write something new on top.
So they were basically reusing paper.
Exactly. And in this case, what they wrote over turned out to be super valuable.
Wait a minute. Are you telling me that underneath some old writing they found, Archimedes' lost works?
That's exactly what happened. These ancient Greek math treatises, hidden for centuries beneath layers of religious text.
That's crazy. It's like finding a hidden treasure.
Hmm.
So what did these rediscovered works reveal?
Well, we got the only known copy of On Floating Bodies, which details his principles of buoyancy, and another one called The Method of Mechanical Theorems. It gives us a glimpse into how he connected math to real-world stuff.
So not only did we get lost works from a genius, but we also got a better understanding of how he thought.
Duh. It's amazing. And you know, we can't talk about Archimedes without mentioning the engineer in him. This biography, it dives into some of the inventions attributed to him. Some are totally plausible, others, well, maybe not so much.
Yeah, it's that mix of fact and legend that makes him so captivating. Okay, let's start with a plausible one. The Archimedes screw. I remember that one from somewhere.
It's that device for moving water uphill, right?
That's the one. I always thought that was so clever.
It's a pretty simple design, but it works. It's a giant screw inside a tube. Turn the screw and it lifts water upwards.
And it's still used today.
Oh yeah, for irrigation, drainage, even moving grain in some places. Pretty impressive for an invention from ancient Greece.
I know. Talking about impressive, this biography also mentions this massive ship, the Syracusia.
The Syracusia. Ah, yes, the legendary vessel.
It was supposed to be huge, like gardens, a gymnasium, even a temple to Aphrodite on board.
It was essentially a floating palace, fit for a king, or, in this case, a powerful ruler.
A floating palace. Okay, now I'm picturing Archimedes sailing around in luxury, conducting experiments in his onboard lab.
Well, the exact extent of his involvement is still debated, but there are accounts suggesting he played a key role in its construction.
I mean, it would have been a massive undertaking to launch a ship that size back then.
Absolutely. And some believe he even used the Archimedes screw to help keep the ship afloat.
Really? Like a bilge pump system way ahead of its time.
Exactly. Whether it's true or not, it shows how his inventions had practical applications on a grand scale.
Okay, so we've got giant screws moving water, a floating palace,
Mm.
and hold on, did I also read something about a giant claw?
The Claw of Archimedes. Ah, yes, also known as the Iron Hand.
That's the one. It sounds like something out of a monster movie.
I know, right? It was this legendary weapon supposedly used to defend Syracuse against the Romans. Imagine a massive arm reaching out from the city walls, grabbing enemy ships.
Oh, while lifting them right out of the water.
Or even capsizing them. It's a pretty terrifying image.
It is. But, given what we know about Archimedes, I wouldn't put it past him to actually build something like that.
Right. Whether or not it actually existed, the stories about the claw highlight the fear and awe he inspired. He was a legend in his own time.
It's amazing how these stories, even if they're exaggerated, add to his mystique. And it's not just the claw. There's another invention, or maybe a rumored invention, that we have to talk about.
Ah, you must be talking about the heat ray.
The heat ray. Now, that's something I've definitely heard of. Setting ships on fire with mirrors and sunlight. Sounds almost too good to be true.
It does, doesn't it? And the historical evidence is, well, let's just say it's inconclusive.
So maybe more myth than reality.
Possibly. But even if it's not true, the fact that people believed he was capable of such a feat speaks volumes about his reputation.
Yeah, like he was some kind of scientific sorcerer harnessing the power of the sun. Okay, but before we get lost in the legends, let's bring it back to the source. What else does this biography tell us about Archimedes' core contributions to science?
Well, the biography really drives home this point. Archimedes, he was centuries ahead of his time.
Right, bridging that gap between, theoretical math and actually putting it into practice.
Exactly. He wasn't just solving equations in his head. He was using them to, understand the physical world.
Yeah, math was a tool for making things happen, not just some abstract concept.
Totally. And his approach, it was so rigorous. He wasn't satisfied with just any answer.
He wanted the most elegant, the most precise, the most mathematically sound explanation.
Precisely. And that brings us back to that whole golden crown thing, the eureka moment.
Oh, right, the bathtub story.
Mm.
But we already talked about how the biography kind of debunks that myth, right?
Yeah, the author makes a pretty convincing case that the traditional story just doesn't hold up, practically speaking.
Yeah, I can see that. The measurements would have been way too precise with the tools they had back then.
Exactly. But, even without the bathtub, the fact that he figured out a solution using a balance scale, it's still pretty remarkable.
Oh, absolutely. It shows how creative he was in applying his knowledge.
Right. He was a true problem solver. But let's move on from the crown, shall we? There's so much more to explore.
Okay, what else is there?
Well, remember that geometric puzzle we mentioned earlier, the Stomachian?
Oh, yeah, the one with the 14 pieces that fit together into a square.
That's the one. It might seem like a simple puzzle, but it actually allows for a ton of different combinations and arrangements.
So, way more complex than it looks at first glance.
Exactly. Some scholars believe Archimedes might have been using it to explore some pretty advanced mathematical concepts.
Like what kind of concepts?
Well, there's this area of math called combinatorics.
Combinatorics. Okay, well, I have to break that down for me.
It's basically the study of counting and arranging objects. Like, how many different ways can you arrange these puzzle pieces? How many possible combinations are there?
So it gets in the realm of probability and stuff.
Exactly. And it's fascinating to think that Archimedes might have been playing around with these ideas using a simple puzzle.
It's like he was making math fun, or at least more hands-on.
Right. And that playful approach, it also comes through in his mastery of the method of exhaustion.
Okay, back to exhaustion. We talked about this earlier, but refresh my memory. How does that work again?
It's all about breaking down complex shapes into simpler ones to calculate their area or volume.
Yeah, I remember the coastline analogy, adding up smaller and smaller segments to get a more accurate measurement.
Precisely. And Archimedes applied this to all sorts of problems, getting incredibly precise results. It shows just how much he was willing to push the boundaries of geometry.
Okay, so puzzles, exhaustion, anything else we need to cover to truly appreciate his mathematical genius?
Well, there's one more problem worth mentioning. The problem of Delos, or the duplication of the cube.
Oh, right, the one where you have to construct a cube with double the volume of another cube, but you can only use a compass and a straight edge.
Exactly. And it turns out it's impossible to do with just those tools.
Yeah, that one stumped mathematicians for centuries.
It did. But Archimedes, even back then, seemed to have a sense that it wasn't solvable in the traditional way. He even explored some alternative approaches.
So he was already thinking outside the box, way back then.
Absolutely. Always pushing the boundaries. But, when it comes to Archimedes' impact on science, there's one discovery that really stands out.
You mean his work on buoyancy?
The one and only. It's the thing that truly revolutionized our understanding of why things float.
Yeah, before him it was all about, like, gravity and
Mm.
levity, right? These kind of vague philosophical explanations.
Right, but Archimedes, he came along and said, nope, it's all about density.
He introduced a more scientific, measurable explanation.
Exactly, and that had huge implications for everything from shipbuilding to hydraulics.
It's amazing how one discovery can have such a ripple effect across so many different fields.
It really is. It shows how interconnected knowledge is and how these fundamental discoveries can change the course of history.
Totally agree. But we can't wrap up our deep dive without mentioning Archimedes the astronomer.
Oh, right, the sand reckoner.
The one where he tries to calculate how many grains of sand it would take to fill the entire universe?
That's the one. Talk about an ambitious project.
It's mind-boggling. What was he even thinking?
Well, I think he saw it as a challenge and an opportunity to explore new mathematical concepts. Remember, he had to come up with a way to express these incredibly large numbers.
Right, like that whole system he developed, which was basically a precursor to scientific notation.
Exactly. And the sand reckoner, it's not just about math, it also gives us a glimpse into the astronomical knowledge of his time. Like, he mentions Aristarchus of Samos and his heliocentric model of the universe.
Wait, heliocentric, like the Earth revolving around the sun.
That's right. That idea was already floating around back then, centuries before Copernicus.
Wow. And Archimedes considered it, even though he ultimately rejected it.
He did. But the fact that he engaged with such a radical idea shows his open-mindedness and his willingness to challenge established beliefs.
It's a good reminder that science is a process, a constant back and forth of ideas and evidence.
Exactly. Even the greatest minds can be wrong sometimes. But their willingness to explore those possibilities, that's what pushes science forward.
Well said. I think this deep dive has given us a really amazing glimpse into the world of Archimedes.
I agree. He was a true polymath, mathematician, engineer, inventor, astronomer.
And most importantly, an innovator. Someone who wasn't afraid to challenge the status quo.
Absolutely. His legacy continues to inspire us today.
It definitely does. And to all our listeners, we encourage you to keep exploring the fascinating world of Archimedes.
Read his treatises, learn about his inventions, and let his story spark your own curiosity.
Thanks for joining us on this incredible journey.